Hello and welcome to this video on automating OpenShift 4.6 installs into AWS GovCloud. My name is Alex Flom and I'm a solution architect at Red Hat. This demonstration has four objectives, which are to perform an installation of OpenShift into a VPC that has no internet connectivity, to manually configure service accounts so that we do not hand admin credentials to the OpenShift cluster while maintaining OpenShift's cloud-aware functionality, to deploy into GovCloud, and to successfully perform a fully automated OpenShift installation with the installer provision infrastructure installation method. As previously mentioned, I will perform this installation using an existing VPC in AWS GovCloud. This VPC consists of four subnets. The first subnet is a public subnet, and this is where the RHEL 8 Bastion host is located. The host has internet access and will be used for generating the OpenShift installation bundle, as well as providing our access to the air-gapped system. The remaining three subnets are contained within their respective availability zones and will provide high availability and redundancy for the OpenShift cluster. The caveat here being that our cloud-aware deployment requires access to the AWS API, which is being facilitated by a Squid proxy and is not shown here. The final piece of our infrastructure is the host that will be used to deploy OpenShift from. During installation time, this host will also provide the container registry service that the OpenShift cluster will bootstrap from. For this demonstration, I will be utilizing the Route 53 DNS service to provide a private zone used during cluster creation. I will be using an AWS account that has permission to manually create the required service accounts and access keys for the OpenShift cluster. And since I'm deploying into an AWS government region for this video, I will also need to upload a Red Hat CoreOS AMI for the cluster nodes to use. The VM import and export requires a role to perform certain operations on your behalf. I will be creating a service role named VM import with a trust relationship policy that allows the VM and import and export functions to assume that role as they perform VM import and export during the AMI creation. This VM import function requires AWS STS to be enabled in the region where the VM import will take place. And I will be using the OC utility to serve a container registry from the installing host in the disconnected VPC. Port 5000 inbound is required to this host from the cluster subnets in order for the cluster to pull its images. You'll need AWS CLI configured on the disconnected host that is performing the install. And finally, if you want to use the accompanying documentation that I made for this video, you will need JQ, Podman, and Git installed on the disconnected host performing the installation. Now, before we get into the actual installation and process, I want to go over some of the resources that we're going to be using and the procedure that we're going to be using to perform this installation. So the Red Hat Gov Git organization OCP disconnected docs repo. Um, Within that repo, I'm going to be using the IPI on AWS Gov Manual IAM markdown file here as our guide. Um, Essentially, we're going to be generating this this bundle on an interconnected host, transferring it over, and then performing a series of steps to deploy this cluster and all of its dependencies into the AWS GovCloud. I went ahead and linked within this document here to, let's see here, the OpenShift 4 mirror utility that we're going to be using to create this bundle. Now, this is under the same GitHub organization called OpenShift 4 mirror, and what this is going to do is it's going to pull down all the components of the OpenShift that are required for the OpenShift cluster for us, and then bundle it into a nice directory structure, um, and then we're gonna compress that and then transfer it. Um, you'll notice that this installation or this bundler also pulls down the binaries we're going to use for the OpenShift cluster management, including the installer and then the OC command binary. So let's go ahead and get started. So for the first step here, we're going to download the entire bundle from various locations on the internet. We're going to need to retrieve a pull secret from Red Hat in order to pull these OpenShift container images, which that pull secret can be found at this hyperlink here. And then once we've copied that pull secret to our clipboard, you're going to go ahead and paste it right here between these two single quotes. So what I'll do is I already have the pull secret copied to my clipboard and inserted in this command. So what I'm going to do is I'm going to go ahead and paste that into my the terminal of my internet connected Bastion. And we're going to let that run for a few minutes. All right, I went ahead and paused the video there while this download was occurring. Shaved off about 10 minutes from the length of this video. So we're going to proceed to step. Well, let's just take a look. There's the there's the directory that was created by this bundler, and then here's the compressed file that we came out with from that. So we're going to go down to step 2 here, transfer the bundle from the internet connected machine, which I'm on now, to the disconnected VPC. And I'm going to go ahead and perform that air gap walk to that device, and then I'm going to pause my video, and then I'll be right back. All right, great. Now I've completed my transfer of the OpenShift bundle, installation bundle to the air gap, and I've staged it on the host where I'm going to be doing the majority of this remaining video from. So I have it right here, and just really quick as an aside, I want to convey to you that there's no smoke and mirrors here. This is a very straightforward process, and so if we do a ping to Google, there's nothing. Ping to Quay.io, there's nothing. This is a completely air gap system that we're functioning in, where we've only explicitly allowed the required traffic to the AWS API to facilitate this installation, and then for the cluster to continue its cloud aware operations. Additionally, as you see me running through this process, you're going to see um, a couple helper utilities and other scripts that I put together. Those are in no way prescriptive. That's not required for this installation. Those are just here for the purposes of demonstration, um, so that you're not watching me editing a bunch of YAML files or whatever JSON objects, particularly around the management of the service accounts that we're going to be creating and their respective policies. So um, back to the process here. We're going to grab this tar command right here. We're going to run that against the bundle. It's a relatively quick process, but I will go ahead and pause for the sake of brevity. All right, great. That decompression has finished. We're going to roll right into getting our Red Hat CoreOS AMI into our government region and available to our cluster. Now, if you have a better way of creating an AMI or publishing this, by all means, please adhere to that process. This is the process that I came up with, more or less from the Red Hat documentation and the AWS documentation that details the creation of an S3 bucket, creating the role to allow the VM import and exporting functions, and then using all of those resources to take a snapshot of that. It's going to be a VMDK that we're going to be uploading, um, and then it's going to convert that into the AMI that would be expected in AWS. So I'm going to go ahead and grab this whole little snippet here, and this is just a smattering of AWS CLI commands, and then I've already included the this role policy, a template in within the bundle, and so we're going to be using substituting these variables in for that. So here I'm going to grab it and great. Now we've created that S3 bucket. We've created the IAM role and policies. Those are all associated and ready. So next we're going to grab, we're going to decompress the CoreOS image, and then we're going to push it into that S3 bucket. Now, when we start this upload, fairly quick because this host is already in AWS. So now we are going to go ahead and create that AMI. So we're gonna use the image in that S3 bucket, and we're gonna take a snapshot of it, and then register that snapshot as the actual AMI. Once again, if you have a better process for this, by all means, please utilize that. We're going to be doing using this little code snippet right here. One thing you'll know about, find out if you don't already know about AWS, for some reason, they love 43%. You'll essentially go from nothing to 43%. It'll stay here at 43% progress, and then it'll be done straight from 43%. There's no in between there. So I'm gonna go ahead and pause the video now while this a snapshot takes place. All right, great. So as you can see, we went straight from 43% to done. So, um, I tried to bake in a little progress bar there, a little counter, using AWS's response, and that's what you get. So, at the very end of this output, we have the AMI ID here. Go ahead and tuck that one away for future reference. All right. So now that we have recorded that AMI ID, we have that AMI available for use with our cluster. Um, as I've said previously in this presentation, we, we're going to be setting up a container registry, and in order to aid in that container registry's function, we need to create TLS certificates, and so I'm gonna generate those certificates. All right, now you'll notice that we have our decompressed directory bundle directory here. We have the registry .cert and registry.key. Those will be used later on. All right. As a quick aside, if you descend into the bundle directory, there's the binaries that we're going to be using for some of the upcoming commands and operations that we're going to be using. So go ahead and import those into your path. I already have them. If you had a previous version of OpenShift install or OC or kube control on your device, um, I would I would strongly advise you to use these versions, because these versions here are tied to the version 4.6.3 of OpenShift that we're going to be installing. Um, you cannot use uh, a mismatched version of OpenShift install. Um, so make sure that you're using the one that's provided to you within this installation bundle. Okay. I already have those available in my path, so I'm going to continue on. There's a install config in the bundle. There's a template we're gonna be using, so I'm gonna go ahead and grab that and put it into make a copy of it that we're going to be using. So I've created this config directory underneath the bundle directory, and within the config directory, all right, let's take a look at um, this template that I've created here for you here. All right, so everywhere where you have these tags is a variable, is a field that it needs to be modified at minimum. So the domain name is the um, domain name that we want to assign um, our cluster. So for this video, I'm going to be using the domain name testocp1.net. Remember, this is air gap. This is private. This is not routable, so I can use really whatever I want here. But this will vary based on your use case. The additional trust bundle here, mind your indenting at the YAML, is going to be the output of the registry.crt that we created in step 8. So you're going to go ahead and paste that certificate here with the begin certificate and end certificate tags. Now, under image content sources, these mirrors, you have to have these 3 mirrors available to the cluster. Don't modify 45000. Don't modify the directory, which we're going to be any of this. Only modify this registry host name right here. And if you look back when we did this step 8, I actually exported the host name of the device that we were on. So use the um, host name of the device you're on and substitute that here. Continuing on, cluster name, This is for the purposes of this demonstration, whatever you want it to be. It's believe mine's going to be test cluster or something similar. As we said, we're going to be using 3 subnets. Your subnets may vary, so add or remove accordingly here. Your region, you must put your region here. I am deploying into the U.S. Government East 1 region. Your availability zones are going to vary based on your deployment. I'm using the 3, as I previously said. And then your subnets. Now, these are the actual subnet IDs. Back here, we were using our subnet and CIDR notation. Here, this is going to be your AWS subnet ID that you're going to be deploying, that these actual subnet addresses correspond to. So your AMI ID was the AMI ID that we recorded from the output of step 6. Pull secret, mind your single quotes here, is going to be the same pull secret that we pulled the bundle down with. And then your SSH key. No quotes here, just the output of your just your SSH key. So, all right, we're going to leave everything else for the purposes of this demonstration to the default as I've laid it out here. So anything that doesn't have the tags, if you're following along, leave it alone. So go ahead and edit that file with your parameters. I'm going to, I have a pre-staged file that I've already made those edits to in only the locations that I've specified by those tags. I'm going to go ahead and copy that over from another directory, and I'll be right back. All right, great. So I just want to take a second here and show you the an example of what those fields and values would look like in that install config. So I have updated my AMI ID. Here's the subnet IDs I was talking about. The zones I'm going to be deploying into, the region. Here's what those subnet addresses look like. I'm using the name test cluster. Here's the host name of the device I'm on right now. And then here's that new certificate that I'm going to be using for the container registry. And then my base domain, like I said, is going to be testocp1.net. All right. So the process that the OpenShift installer uses when provisioning a cluster, it will actually take that that installation configuration we made and it will consume it, which means that you will not have that file available to you once you kick off this installer. So what I like to do to make my life easier is to create a copy of it, so that if something went awry, if I fat fingered something, if something was wrong in the installation process, I can quickly go back and then I don't have to enter all those values into my install config again. So let's go ahead and just make a quick copy of that, and um, let's see here, and then we have a config.back, which is there. So all right, so this is the process I was talking about, where it's going to make it so you no longer have that available to you. All right, great. We have our manifests, and we can just peek in there. manifest directory and OpenShift directory underneath the installation directory. That's what's inside of those. All right. So the first thing we want to do is it's going to use your current the AWS credentials from your current AWS CLI context in the installation process. We want to remove that because we're going to be using different service accounts that we're going to manually create. So I'm going to take that secret out from my that was used during the configuration process. All right, so next we're gonna we're gonna manually create those service accounts and associated policies that OpenShift is going to use during its cluster lifecycle. Depending on the policies and procedures of the organization, this process is going to be different. The account I'm using right now, my AWS account, has the permissions to perform these actions. So I'm going to go ahead and use these convenient scripts that I've made to use the policy templates that I've created and create those users, associate those policies, and then generate the secrets for those accounts. So I'm going to go ahead and use that convenience script I've created. I have bash verbosity on maximum here. So we can quickly identify if there's going to be an issue in the execution of the script. Great. Those accounts and policies are now created. And then I've created the secret helper, which is just going to create generate the access keys for those service accounts, and then it's going to put those into Kubernetes secrets manifests. They're going to be used during the cluster um, bootstrapping. So, and then here we're gonna transfer those Kubernetes secrets into the installation location of the cluster. So let's go ahead and do that. Great. Now we have our secrets, Kubernetes secrets for those service accounts created and in the installation directory for our cluster. Take a look at those. Great. 6 service accounts that were created, and there should be this OpenShift um, machine API AWS secret. All of these are going to be suffixed with this secret section right here. So all of those are there as expected. Great. So next we're going to start the OC image container image server, which is a really nifty new feature of OC. Um, Still marked as experimental, so use at your own discretion. Um, but it does the trick for the purposes of this demonstration. Um, we'll go ahead and run that in the background. And finally, once the server started, go ahead and deploy the cluster. Okay, while this process is running, and it will take a while to run. So what I usually like to do at this point, where we're creating this infrastructure, at this point in the installation process, is I use a watch command that's going to be to get the cluster operators with the kubeconfig that the installer created. So I'm going to set up that watch, and you're not going to get any output here, but as this process progresses, um, as the Cube API becomes available, um, then we're going to start getting a good picture of which cluster operators are progressing and which part of the bootstrapping process our cluster is in. So I'm going to go ahead and let this process run, and I'm going to go ahead and pause, and then we'll be right back. All right, great. Quick status update. It looks like the infrastructure is finished creating, and then we're going to wait until the Cube API becomes available. So that's just an update of where we're at. The container images are still being pulled into those bootstrapping resources and into the manager nodes. So we're waiting for those containers and those pods to come up. But we have progressed. The installer has progressed, and then we're gonna go ahead and pause and be back when we have another status update. All right, wonderful. Looks like the Cube API is up. And then we're going to continue waiting for the bootstrapping to complete. As we go through this process, um, our wait down here for those cluster operators is going to continue progressing. And I'm going to go ahead and pause and then periodically just come back on and show you what this matrix is looks like and how it progresses through our cluster provisioning. All right, a couple minutes have gone by. Our cluster is now further along in the provisioning process. My grid now, this matrix is populating as this information becomes available from the Cube API. And as we continue progressing through this process, if you're keeping an eye on your AWS console, you'll see um, the bootstrapping node and master nodes, 3 master nodes, um, present EC2 instances available um, and working. We'll go ahead and pause again and come back as when we get our worker nodes up. Quick status update. Just wanted to share my AWS console with you. My EC2 console shows a bootstrapping resource, 3 master nodes, and 3 worker nodes. Your mileage may vary as far as when these become available and the status of your grid here. Um, but that's where I'm at right now in my process, and I will pause and be back shortly. All right, we've reached another milestone in our bootstrapping process. It was waiting 30 minutes for the bootstrapping to complete, and then we come to this point where the bootstrapping is considered complete, and the bootstrap resource is then destroyed. So we're going to go ahead and wait again until the final stages of our cluster provisioning are completed. Wow, all right. We have a functioning cluster available. It looks like all of our cluster operators are available, not degraded. The installer has completed, has given us the instructions on how to export our kubeconfig um, variable so that we can use our Kubernetes management utilities with this current cluster. And then we have the OpenShift console, web console credentials here. Total time for cluster creation was just a blazing 48 minutes, 34 seconds. And so now what we're going to do is I'm going to set up an S shuttle proxy from my laptop here at my house uh, through that Bastion node um, where we pulled down the OpenShift installer bundle. And then I will access the web console as a quick function test of this cluster, and then we're gonna wrap things up. So one moment while I get my proxy up. Okay, So I've started my SSL proxy through that bastion. This is going to simulate me being in that disconnected environment co-located with the cluster. If we were in a totally air-gapped organization, um, this is something that each organization is going to do differently, whether all their infrastructure and resources reside in that air gap, or they proxy these connections through something like a bastion is going to be completely dependent upon your organization's policies. Um, but without those restraints, I'm just going to use this proxy through the bastion. Now, if we look at um, access to the OpenShift web console here, and then it gives us this neat URL. I'm going to go ahead and throw that URL in there. And of course, we don't have the web server certificates configured yet, so we're going to have a non-secure connection to the OpenShift console. And you can see here that I'm in that testocp1.net. So this is, of course, not a valid domain anywhere other than my offline environment and the proxy. So we're going to go ahead and get my credentials. Cube admin is going to be the username. All right, great. So here is the functioning OpenShift um, console, web console. There's going to be some day one, day two administrative things we're going to have to do here, including getting getting rid of that OC image server and putting something more robust, a more enterprise solution, and for retrieving those images in the future, which is what you're seeing here. These errors, we need to go ahead and point our cluster at a better registry solution. But this is absolutely okay for just to get the cluster up, get our foot in the door, and get started with OpenShift 4.6 in an air-gapped or disconnected setting. I'd really like to thank you for spending this time to go through this process of installing OpenShift 4.6.3 into AWS GovCloud in a disconnected fashion with the IPI installer. Feel free to give feedback on any of the resources we're using in this video in the GitHub comp issues or pull requests. And thank you very much for your time.